With the first case, switch is open. This is a 2 ohm. This is 6 volt. Where all the current can flow. Capacitors, in place of capacitor will be open circuit. The current will take a path like this. Polarity plus minus, plus minus. So what is the current? Current will be I equal to 1 ampere. This is the current. So these are the capacitors C1, C2. What do you expect the charge in them? So when they're getting charged, what charge flows through this capacitor? The same charge will pass through here also. No? When getting charged, the charge will flow, a current will flow, and a current will flow. What current flows here? The same current is passing through this. So therefore, the charge in them will be Q. Steady state is asking. No? So therefore, Q minus Q, Q minus Q. So you can use potential divider formula or anything. It's left to you after this. So what is V1 equal to? 6 into C2 by C1 plus C2. C2 is how much? 4. 2 plus 4. So this will be 4 volt. So what is the charge equal to? Q is equal to C1 into V1. This is 2 into 4, 8 coulombs. This was the steady state charge across them. If I'll ask you find the potential at point A, find the potential at point B, find the potential at point C. What is the method? KVL. So apply KVL. VA minus Q by C1 minus Q by C2 minus 2 into I 0 equal to 0. Why 0 I should write? Because what is the potential of Earth will be 0, no? Or you can do one thing simple. You can come like this, no? Another path. What is another path? You are saying VA minus 6 minus 0 equals 0. This is a path, no? Or you can choose another path. Cross-checking whether you are right or wrong. You can cross-check, find out potential using two different paths. Potential must be equal. If they are different, then something went wrong with the calculation or the assumptions. Similarly, you can calculate the potential VB, VC on. Okay, there's the first part when a switch, when first case, when switch is open. Okay, after closing switch. So what will be the steady state charges across them?
Sir, sir, how did you get Q equal to 8 coulombs, sir?
C1 into V1.
Sir, the V1 is not 4 volt, no, sir, because the potential difference between.
Oh, wait. I think calculations went wrong. So it will be, it come 4, no?
AC is 4, no, sir.
C2 is how much? 4. C1 plus C2, 2 plus 4. Applied voltage is 6.
Okay, sir. Yes, sir.
Fine.
Right.
Okay, we'll go for the second part of the problem. With switch closed here, I'll give the circuit. Nothing to do with earthing. See, like I'm just not bothered about the earthing. Just only to define that zero potential point. The switch is closed now.
Right. Sir, in the previous one, VAC is 4, but V1 how it is formed.
What happened?
Both equations are not satisfying, sir.
Which equations?
Sir, here you wrote, no, sir, VA minus 6 minus 0 equal to 0 and VA minus Q by C1, that one.
There is no unknown, sir. There.
Sir, VAC is 4, sir.
VAC is 4, huh?
Yes, sir.
Substitute QI and substitute I.
So there is only current in the lower loop, so we can say
Nothing
Q.
to do, nothing to do, nothing to do. I'm just writing loop equation. What is there in that one?
Sir, in the above thing, it's the equivalent capacitance is 4 by 3. In the loop, there is current 1 ohm,
Say,
1 ampere.
leave all, calculate VA by first equation. Will you get same answer or not?
No, sir.
Check it once.
Sir, in first equation, in the loop equation, you forgot to write. You
Wait,
forgot
wait,
this,
wait.
sir.
VA will be 6 volts, sir. Correct or no?
VA will be, so if I write loop equation, VA equal VA minus Q by C1 minus Q by C2 minus I into 2 equal to 0. Finish over. I don't know what I forgot here.
VA is 6, but VC is 2.
Let it be, no problem.
So then VAC is equal to 4. Then 4C2 by C1 plus.
Oh, so sorry, the drop. Yeah, I got it. So this, the drop here, this V1 plus V2 drop, 6 volt will not come. Yeah. This will be 4. Yeah. The drop across this 2 ohm will be shared, not 6 volt. Because this drop is what? Will be shared by those two capacitors. No? Able to make it out? The drop across this 2 ohm will be shared by these two. Okay. 16 by 6 will be 8 by 3. So this will be 8 by 3. 16 by 3 coulombs. It should be this much. Now check it, it will match it. So some correction is needed here. It should be 4. Okay, fine now. The potential drop across this 2 ohm will appear across these two capacitors. The two capacitors will share the drop across of these two resistors in series. Because this drop will not appear across the capacitors, no? Yeah. Okay. Thank you for correction. Now let's come for this. I'll close the switch now. Switch is closed here. This is 2 farad. In this case, now how we have to make it? So again, the at steady state is asking. So no current flows through the capacitors. Plus minus. This is a thing. So what is the expression for current I? Again, it will be value will be same. So I is equal to how much? Will be equal to 6 by 2 plus 2. 1 ampere. What should be the drop here? The 2 volt, no? This 2 volt will be shared by this. This 2 volt will be shared by this. So the charge across them will be different, no? Q1 minus Q1, Q2 minus Q2. So Q1 equal to C1 into 2. C1 is 2 into 2. This will be 4 into 2. 4 coulomb, 8 coulombs. They are not now in series. So you have to be very particular about like the switch when it comes closed open. No, what will happen to the circuit? How the capacitors, will they series, parallel? Earlier they were in series. Now you can't say they are in series. The charge in them the charge across them will be different. The drop across this 2 ohm, the drop across this resistor will be the drop across this capacitor. The drop across this resistor will be the drop across this capacitor. To cross verify, again the same method. You calculate the potentials. It should match. Whether you are right or wrong, you should check with your find out the potential at point A using two different paths. If you get same answer, it's correct. Otherwise, something went wrong. Okay, we are doing again the problem at t equal to infinity at steady state. That's why the capacitors like open circuit they are.